I see many of you have the same jacket as I do. So thanks for coming. The talk will be about chatbots and microservices. And a few questions to you to understand who actually you are. How many of you are programmers? Oh, great. And DevOps? None. Almost. Okay, good. And managers? Not so many. Great. Because I had an impression that the conference is more on the angle of the management side, but now I understand it's more technical, which is good because the talk is going to be quite technical. But I'm not going to show any code examples. I'll give more of the overview on the architecture side. I've been talking about these chatbots and microservices for the last year, and every time I'm trying to convince people that this is a good way to go, this is the right architecture, this is the future, that chatbots should be everywhere, and we're gonna design our services as chatbots. But today I decided to give the dark side of chatbots. So I'll give you examples of how many problems we had with these chatbots, with actually one chatbot, which we designed about 2 years ago, and I'll show you problems which we had, which is going to be quite interesting because I've never talked about that. It's just the first time. And I'm a little bit nervous about how you're going to react. So first of all, I'll explain what kind of chatbot I'm talking about. The system is called Rulter. Who of you actually heard about it? Not so many. Okay, the idea is that it's a hosted system. It's a chatbot which talks to you if you're a programmer. You have let's say it works on GitHub. So you have a GitHub project and you create a ticket in GitHub, the GitHub issue, and then you start talking to the system by saying @, then the name of this Rulter, Rulter, and then you say some keyword. For example, you say hello. You say Rulter hello, and the chatbot is listening to everything what is happening on GitHub. And as soon as this message shows up, the chatbot Rulter answers you and says, "Hello, how are you? You can give me this kind of commands." And we support just basically 3 commands: merge, deploy, and release. So let's focus on deploy. So you have a GitHub project and you have some code in there and you want to package this whole code, create, let's say it's a Java application, you create this jar file and then you deploy it to production. So you say Rulter deploy. The Rulter starts on the server, on its own server, starts a Docker container, gets your source code from GitHub, packages it, and puts it to the production server, according to the script which you created before. So you have to create a script which you put into your repository, the script which explains how this deployment should work. So the Rulter basically gets your code, packages it, and puts it to production server. Quite simple. The difference between this system and all other systems which does almost the same is that it works as a chatbot. So there is no control panel. So you don't go anywhere and say, deploy my stuff. You don't have to log in anywhere else. Everything you do is you go to GitHub, you create an issue there, or you stay in the issue you have already, and you talk to this system over there. So you don't need to go anywhere else. It's a chatbot. It works like a system which talks to you in the conversation thread, which is GitHub issue. That's the difference. And the main architectural difference is that's what I've been talking about for so many times, is that the key difference between this architecture and the traditional architecture, when the system stays aside, for example, from GitHub, and you have to log in there and say, do something with my GitHub project, and then you control the execution over there, you click some buttons over there. So you don't talk to the system through this chat communication channel, but you use the control panel. The key difference is that, in our case, this Rulter system works as a client. So it connects to GitHub and it works as a client instead of being a server where you have to connect to and talk to. So if you compare this system, for example, with Travis CI or Circle CI or any other continuous integration services or Jenkins, every time it's some server which is expecting your requests, waiting for you to connect to them and helping you out being a server. In our case, and the key difference, and this is for all chatbots, the very important advantage of the architectural advantage is that each chatbot is a client. It's not a server which is supposed to be online 24/7 listening to your requests. Instead, it's a client who is connecting to this communication platform, which is in our case GitHub, but in other cases it could be Slack, for example, or IRC, or any other platform where you basically post messages. So in our case, this chatbot, and in all cases, it's a client, not a server. And this is the key difference which gives so many advantages for the architecture. And basically, there are 3 benefits, which are the most important in our case. Why we started to do it in a chatbot 2 years ago. Basically, I did it. I created this system, and there were 3 main things which were driving me, and that's why I decided to do it in this way, without the control panel, without being a server, but in a chatbot format. The first thing is that there is no user interface, and that's why it's so easy and so simple to develop and create. There's no user interface, no buttons, no login page, no front end. There's nothing like that. Everything is just a back end which talks to GitHub issue and posts messages and reads messages. So there is no need for me, 2 years ago, there was no need for me to design a complex UI with this good-looking interface, CSS, HTML, the things which are not really professional at. So I'm a Java developer, I don't know how to design the good-looking UI. And it was not necessary because for the chatbot, there is no UI, which is a big advantage for the architects, for programmers. They don't need to be UI. There's no need for the UI and a UX design at all. It's a chatbot which just talks, posts text messages, and gets text responses back. And that's it. That was the big thing, number 1, which is why I decided to go this way. That saves me a lot of time. The second thing is that, like you imagine what's going on, I get when you ask me to deploy something, I get the GitHub sources. I need to package them. I need to run Docker container. I need to do some work on the server side. Then I need to deploy that. It takes some time, sometimes a few seconds, sometimes a few minutes, sometimes an hour. And then I have to reply back to you and say, what's the answer? What's the result? What actually happened there? So it's quite time-consuming operation. And to do it right in the UI form, when you're sitting in front of the monitor and clicking buttons and expecting me to answer you, well, immediately, it's quite difficult. So you're clicking the button, you expect this button to react immediately and say something back like, yes, the server was started, or the Docker container was just started a second ago. But I can't do it in half a second. It takes sometimes a few seconds. It takes sometimes maybe half a minute even to connect to the server and start this Docker container. So it's time-consuming operations which do not go along well with the UI. So the idea of the UI and UX in general is that it's fast. So it has to be fast. People have to be able to click there and immediately get some response back. But in our case, it's not so easy because there are servers involved, and sometimes many servers. It's a back-end operations. So, but in the chatbot, we don't have that problem, because you post your message on the GitHub, on the thread, on this communication issue. You post a message, and you can wait for a minute for the answer. You can wait for a minute. You can wait for 2 minutes. It's okay for you to stay and wait if you're talking like that in a chatbot mode, which is an advantage, I think, for all chatbots. For all of them, because there is no UI, you don't need to be fast. When you design your chatbot, you don't need to design it really fast. You don't need to be responsive. You don't need to answer in 50 milliseconds. You can really answer in 1 minute. It's acceptable. The person who is posting messages to Rulter in GitHub, they are usually expecting an answer within a minute or maybe sometimes 2 minutes. A few milliseconds there and here, or maybe a few seconds, don't matter to them. And that was a big advantage again, because I don't need to worry about how to answer you immediately when I'm still talking to the server and trying to do something there. That's the second benefit. And number 3, which is also really important in this case, when you do something with the server, you want to track your execution flow. You want to keep log of everything what's happening. You don't want to forget that. And when you have the control panel where people log in there and they click the button and they say, do something with me or get my code, package it, deploy it, you need to think about how to record everything, what happened there, what commands were given, how they were executed, why they failed, and everything. So it's not so easy to design this interface. If you go to any of these CI systems, you see the button build. When you click the build or run or whatever, it builds and you have the log of this last execution. But if it fails, then you have to build again, and there is not really direct connection between these 2 builds. So you don't know what exactly was changed between build number 1 and build number 2. So it's not so easy to track everything and make it traceable. In case of GitHub and in case of this chatbot and all chatbots, there's a chat which goes from start till the end, and all commands you post there and all answers my chatbot is giving to you, everything stays in the same line. So you can get back to it in a year and see what happened a year ago, how we tried to deploy our GitHub project to production or to Maven Central, for example, and why we failed 3 times and then we succeeded on the 4th attempt. So you see everything. We tried, and then the answer from the chatbot is, you know, guys, we just failed, and then we changed something in the code. We connect this, we attach this commit to the issue, and we see what we changed, then we try again, then we commit again, and then it may be like 100 messages, and then there's a success in the bottom. So the same traceability, it's really difficult to achieve if the architecture is not the chatbot architecture. So that was number 3, the benefit number 3, which for me was very important. So all this traceability is provided to me by GitHub. So I don't need to build it myself. I don't need to build all this functionality of tracking what's going on, of seeing these messages, of seeing people communicating to each other, of this authentication and authorization, login, logout. All this functionality is just provided to me by the communication platform, which is GitHub. All I do is just creating a client for this GitHub, which talks to the communication platform, which is GitHub issue, and just post messages and gets answers back. So that was really important, the 3 things which really, you know, was motivating the architecture to make it in the chatbot way. But at the same time, we've got problems. We've got problems which I was never talking about before, and now I'll try to highlight these problems for you. 7 of them. There were many more, probably, but I want to show 7 in the order of importance. First one is not so big a problem, and then bigger and bigger. Is it clear so far, up to this point, how it works technically, right? Okay. So problem number 1. Which I'm showing you the problems which I faced when I started to design that, and I faced that problems, and I was solving them. Problem number 1 is that when you have this chatbot, and the chatbot is supposed to talk to people, sometimes you make mistakes in your chatbot. And sometimes your chatbot will post some garbage into the communication channel. So people start talking to the router. They say, for example, deploy my code, and there's a bug in the code, in the router itself, and it keeps saying like, yes, I will deploy it now, yes, I will deploy it now, yes, I will deploy it now. And then you see like a lot of these garbage messages, and if it's, for example, nighttime, then you come back in the morning and you see like 50 messages there. And that kind of garbage, like, people don't really like to see, and they immediately realize that there is some problem there, and this is really annoying, and you don't want to see, you really embarrass yourself like a developer. And it's inevitable, because sooner or later you will have bugs. Sooner or later you have bugs which you can't predict, and this is the way they may show up. So basically we introduced 2 solutions. The first one is we created a filter, which was, I'm telling you all of this maybe because you will design something in the chatbot format. So maybe this information will be helpful for you. I'm just sharing this solutions, how we solve that. First of all, we created a filter which, before you post anything to the chat conversation, it checks how many posts from myself, from me, the router, were posted before. If the number is 4 or more, it doesn't post anything and just keeps, stays quiet and reports a bug to me. So 4 was the maximum. If there is more than 4 messages, then probably something is wrong. So I'm not supposed to say too much unless somebody is replying to me. So I'm just basically, router is basically checking the last messages. If the last 4 is from me, from router, then nothing is posted. Then that's one filter. And another one is, if you see, it also checks the previous posts, and if it finds, and it knows exactly what is supposed to be, what is going to post right now. It compares the text, which is going to go right now, with the text stays there. So if the texts are the same, then again, it understands that this is a duplication and it doesn't post. For example, the same filter exists on Twitter. If you want to tweet something and then you will try to tweet exactly the same, the Twitter will block your post. So if you by mistake or through the API or try it from your phone, if you tweet exactly the same text twice, Twitter will just reject you. So we did exactly the same. So if you post twice, router by itself, it just tries to prevent this garbage from happening from the communication channel. That was one problem. Another problem, the problem number 2, is a bit more complicated, is silence. It's not the garbage, it's the silence, the quietness. So when somebody starts talking to router, there's no answer, because there is some bug on the server, for example. If it's a UI, if it's a control panel, then you go to control panel, you start clicking the button, there is no response, the server is down, you immediately understand what's going on. In this case, users cannot really understand what's going on because they are expecting an answer usually for, let's say, in 1 minute or 2 minutes. But in the case of the error, they post something and then in 2 minutes there's no answer, in 3 minutes there is no answer, and then they don't know what to do. You cannot show them some page which like, hey, how about you wait for some time or email us or let us know. So there is no conversation with them. There is no point of contact with them. And this is a problem with chatbots. With traditional architecture, you have a page. You have a page where people can see something and then you can go show them some status. Even if your server is down, you still your name server points somewhere where you can show them at least some static HTML page. In our case, there's no way to show them anything. Because if the chatbot doesn't answer, it doesn't answer. And for all chatbots, the same. Like if you design a chatbot for Facebook, again, people start talking to you, for some time you answer, and then you don't answer, only the administrator can understand what's going on. Because there's no way for the user actually to contact you anyhow, because there's nobody in the chat room, and boom, there's no point of contact. How we solve that? Well, we had to create a page. We had to create a page like the web page, which is router.com. And on that page, we just show the status of how good we are right now. And internally, this chatbot, probably all the chatbots are designed that way, it's a cycle, endless cycle inside. It's a Java application. So it's an endless cycle inside which connects to GitHub, checks for all notifications, all the new messages for me, does something with all of them, and disconnects. Again, connects, checks all of them, does something with each of them, and disconnects. And this cycle goes every minute. That's how we do it, every minute, because we cannot do it more frequently, because GitHub will, prevent that, and we don't want to make it slower because, we want the responsiveness to be 1 minute or maybe 2 minutes maximum. So we run this endless cycle. Every minute we connect to GitHub asking, do you have anything new for me? And the GitHub gives us notifications. So when we stop running that, let's say there is some bug and we can't run the next cycle. So we stop trying and we just stuck, and the cycle is not going anywhere. And what we do is that we create in memory, we create a simple pool of a simple array of statuses of the last runs. So every time you run, you put some short piece of information into this array, like the time when I finished. You run it again, you put the time when you finished. You run it again, you put the time. And then on the status page, we show to the people, to the public, the situation of this array. Like when was the last run of our cycle? And if the last run is longer, like the time between the last execution of this cycle is longer than 10 minutes, then we show that, boom, there's a problem. Like we put it in red and say something is wrong in our system, which is an information to the user that something is wrong and probably you need to wait or let us know or email us. That's the only way I think chatbots can be designed. Because like I'm saying again, from the communication, the normal interface, from this channel where people talk to us, there's no way to understand that there's something is wrong. So we designed this front page, and also we configured this. I don't know which system you're using. We're using statuscake.com, which is the system which you can configure to check your websites. It's free. So it basically every minute it pings your system. It makes the HTTP request to your servers, and if something goes wrong, it emails you or sends an SMS to you or sends you some kind of notification. There are many systems like that. We're using Statuscake. So we configure Statuscake to check this situation on the front page, and if the time of the last response is longer than 10 minutes, then it basically gives us an alarm, and I'm getting the SMS or something, which something goes wrong. That's the only way to do it, I think. The only way to do to solve this problem of sudden silence in chatbots. Problem number 3. Is it clear up to this point? I hope so. Okay. Problem number 3. Verbosity. These chat communication platforms are not designed to display messages of 1,000 lines. So they are basically for communicating human to human, like GitHub issue or Slack or IRC. You cannot post, well, you can probably, but it's kind of look ugly. It will look ugly if you post on Slack or on GitHub issue the log of 1,000 lines. Everybody will complain. All the users will complain that you're just taking like 15 pages of my screen just to look at the log, which I don't need to see that much. I want to see probably the last 50 lines or last 10 lines or maybe the start. So I don't want to see everything. But in our case, when you ask our system to deploy something to production, then we do it, and then there's a log generated, sometimes at 10,000 lines of code. So what do we do with that? So how can we bring you back the information, which is so huge? That was a question for us. Because people are expecting to get something back from us. They're asking our servers to do something for them, and we need to give them information back. And that was the question, how exactly we can do that without basically violating, probably there's some, I don't know, but maybe some rules on GitHub that we shouldn't spam them that much, should not post such a huge blocks of data. So the solution was to introduce some standalone interface for the chatbot. So the chatbot talks to you using messages, but at the same time, sometimes it posts a message and says, that's exactly what happened, but there's a link which you can click and go there, and then you will see the full log. So we're still talking to you as chatbots, but sometimes we're asking you to go somewhere and look at the website. It's not a real website, it's just a text, it's just a plain text page. But this plain text page is somewhere else. So it's a chatbot, but still it has, like I'm saying, there are basically two extra interfaces. One is to show you what's going on, because without that, it's going to be a problem of silence, which is unsolvable otherwise. And the second is another interface, which shows you big blocks of data, which you cannot show anyhow otherwise, without basically spamming and annoying your users by big blocks of data. So that's how we solve it. And sometimes we also do, if there's something wrong happened on the server, we say that you can see the log over there, there's a link, but we also show the 50 last lines of the log, which helps people sometimes quite often. So we're not just saying that you can see the log only there. We're saying this is 50 last lines, which is more or less okay for you to see in the text chat mode. But the full log, you go over there and you find it there. So that's how we solve the verbosity problem. Problem number 4, there's 7 total. Problem number 4 is abuse filters. It is still a problem. It's not completely fixed now. So I think most systems, and GitHub, for example, they are not really designed to be intensively used through the API by some bots, by chatbots. So when you start posting a lot of messages there, or you start checking the notification and everything, they have certain limitations. That's first of all. So they do not allow you to make, if I'm not mistaken, 5,000 requests an hour. So for every hour, you can connect to their API and make the maximum of 5,000 requests. That's the maximum. If the usage of our system is really intensive and we have many requests, then we sometimes go over this limit. And GitHub doesn't want to increase that limit. We tried, we talked to them, they say, no, this is the limit we have for everybody. So it's 5,000 an hour, which could be a problem. Maybe other systems have the same kind of limitations. But that's just half of the problem. Another half is that sometimes, and they have many filters inside, which they don't disclose, they don't explain how they work, but sometimes they just say, we cannot process your request right now because you just triggered our abuse filter. So they think that our API, our server, is doing something wrong, and they shut us down for some time. Sometimes for a few minutes, sometimes for a few hours. And it's unpredictable. And you can't control, you can't anyhow, I mean, we tried, we emailed them, they say sorry about it. When you email them and say there's something is wrong, please unlock us, remove the ban, they say sure, of course, we'll do it right now. But then in a few days, but now it happens like once a month, it just starts banning you, starts blocking your requests and nothing, and you cannot do anything. So we're just receiving this silence problem. The server just stays quiet, it can't work, because GitHub as a platform basically blocks us and doesn't allow us to communicate with them. So that kind of problem, I don't know exactly how it could be solved. Maybe on Slack also something like that will exist. Maybe they will also try, because they need to protect themselves. They need to filter out the behavior which is not really the behavior they expect. But in our case, we intensively use the API. We need to check every minute. We need to post messages. We need to read messages. So we use their API, and they filter us out sometimes. And I don't know what's going to be the good solution. The only thing we introduced, the only thing we did is that this limitation of 5,000 an hour, we just track how many requests we do. And if the number goes above 5,000, we automatically slow us down and don't run this cycle every minute, but we run it like every 2 minutes, every 5 minutes. So we slow down our own execution in order to not go above the limit. because we understand that if it goes above the limit, then it's just a big problem, and from the API, we're just receiving the 40404 or some really like error messages from their server, which makes our software really unstable. That's the problem. And now the problem with conflicts. Even bigger problem. Conflicts between 2, 3, or many chat channels. So let's say we have a project and the GitHub project, and there are many issues. And in each issue, the communication goes. So people start talking to Rulter from one ticket, and then from another ticket, and then from another ticket in parallel. And we need to somehow resolve that, because we don't want to deploy from two different tickets. If I ask you, if one programmer asks me to deploy the entire code staying in one ticket, and then another guy says deploy from another ticket, I don't want to start 2 Docker containers and deploy in parallel, because that will create the conflict on the production server. So I want to somehow put these requests in the line, in this, like sequentiate them. So they have to go sequentially, one after another, in order to avoid conflicts. Because we've had that conflicts in the beginning. We didn't know about that problem, we didn't expect that, and then we realized that, boom, sometimes people actually do request in parallel, and then these conflicts appear later on production, and we can't understand why. Because one of them will receive the error message, which is really unpredictable, and it will be difficult to understand for one programmer why it happened, but actually it happened because of another programmer. So you need to put these guys in parallel, but it's not so easy, because every time, because you try to design your chatbot as a client which connects to the server, asks what needs to be done in some thread, and does it. And then in another thread, it connects again to the server, gets another notification, and tries to do something else. So there are 2 parallel threads which needs to be somehow synchronized between each other. And this synchronization needs to be, on the server side. So initially we were trying to design our chatbot as a stateless machine, which just does exactly what needs to be done in one situation. Just do the work and close that, and don't keep the state, don't save it anywhere. But then we realized that it's not really possible, because in order to resolve conflicts, we need some locks, some mutexes, something on the server side which will resolve them and inform each other that you need to wait for another one. You need to wait for thread number 3 because it's working on exactly the same project or on exactly the same command. So that was a kind of a big problem, and I think it's common for most chatbots. So when you talk in parallel to 2 people, you need to store some information on your side, on the back side, about the situation in general. You cannot be completely stateless. You cannot completely ignore the situation. You cannot just talk, which brings us to problem number 6, statefulness. So like I'm saying, we were expecting to make this machine stateless. But then we realized that we need some statefulness, which is not a problem if you design your microservice in a RESTful API, and it's completely RESTful and completely stateless. In this case, the client connects to you, gives you the order, tells you what to do, you do the work for the client, you return the result, and you forget about the client. That's how RESTful API should work. In our case, we tried to do it that way. We tried to design this chatbot the same way. You connect to the GitHub, you get the notification, you process the notification, you forget about it. But you can't do it because, for example, I'll give you a practical example. That the user says, deploy my stuff. And the chatbot connects and say, the command is deploy. And the bot says, okay, I will deploy right now. It goes to the server. It starts the Docker container and says, do this work for me. And then it closes the cycle. And it's just done. I'm done. I just started the container. And then it goes again. The next run, the next cycle of execution. And it checks, what's the situation with the container? It's still working. Okay, I don't do anything. Again, the next cycle, it goes to the server and says, what's the situation with the container? But every time it goes like this, it needs to remember, where is that container? So that's the state between these executions. On the beginning, on the first request, we just started the container. I have the container number, Docker container number. I need to save it somewhere. I need to save it and attach this number to this communication thread. So I need to remember that when we are talking, the command was deploy, and this command is attached to container number 1, 2, 3. And then on every run, I will check many, many times what's the situation with that container. the container is alive, it's alive, it's alive. I can check many times, 100 times, and then suddenly, at one point, the container is dead, which means that the command is finished. I need to go to the server, grab the data from there, all the logs and everything about the container, why it finished, I mean, what's the result. I'll get all this information from the server, and I need to post that on the conversation and say, you know what, the container is just finished, it took me 1 hour, that's the summary. So in order to do that, I need to save the information about the container. I need to keep it inside my database. And that was not so easy because we never know how many more conversations we are expecting. So every time we go to GitHub, and every time to go to chat platform, which is GitHub in our case, we don't know how many more tickets we have for us. We don't know how many more people are talking to us right now. Every time we just open the door and look what's going on. And the GitHub says, you know what, you have 15 more notifications for you. So there are 15 more people want to do something with you. And you need to, for each of them, you need to start something new in your database. So you start this conversation in your database. You say, okay, now you're talking to me. This is the command coming from you. I start something in my database. And the next run, I go back and I don't see any notifications from that guy, but I know that the conversation is going on. And that keeping track of that conversations is not really an easy task. It took us some time to figure out how to do it right. Because sometimes, the biggest thing is that if you lose something, if you damage this information somehow internally, you lose the entire communication. You basically, many problems which I explained before will be caused by your failure to keep the state properly. So if something is wrong, if you lose, for example, the number of this container, it's a huge problem. You started the container and then you lost this number, so something is going on the server and you don't know what. So you can't report to the user, you can shut down the container, you can't manage the resources. So you need to really keep track of that information, and it's not so easy. I don't want to go deep into details, but I'm just saying that this statefulness is a problem, I think, for all chatbots. Comparing to the control panel systems, where everything is through the API, and every time the user connects to you, the user brings the context with you, with himself. So the user comes to you and says, I'm the user, this is my ID, you can find me in your database, so I'm talking to you, and it's restless. I mean, it's restful. So I'm coming to you, and I give you all the information about myself, serve my request, and I'll go away. So it's completely different design. It's way easier to design it that way, comparing to chatbots. And the last problem, which is I call fragility. That's annoying. What I mean here is that in some situations, and in our case, in most situations, if it fails, if something crashes on the server, if there is some bug, then basically it stops talking to everybody. So right now we have for this chatbot, we have about 300 projects and people talking to us like every day. So all these people, they rely on us, and they know that if they say router deploy, then something will happen and the code will be deployed to production. And they rely on that fact. And then some bug happens. I can give you the practical example which happened 3 weeks ago. The summary is that if something fails, then it fails for everybody. The 300 people just stop and they cannot work because one bug is there, and you need to fix that bug, and then the chatbot starts working again. Which is probably not the case with the systems where they have control panel. With the control panel, usually when there is some bug, this bug shows up in some specific click of a button. So you can click certain button, you can do some specific feature. In our case, in most cases, that's my experience. Maybe in some other designs of chatbots it will be different. But in my experience, we make some bug and the software fails, and it means that all people who are talking to the software cannot talk anymore. It just crashes. And it takes some time for us to restore the situation. And if it happens, for example, on the weekend, then it takes a few hours. And that's really annoying. So we had this problem 3 weeks ago. One guy, I don't know, it's open project, so it's free, so anybody can use it. So he had a code that was Java application, and he created the code, and he gave the command deploy. And we started the container, and we started to deploy that code. But then while the deployment was happening, he changed the configuration of the configuration file in the repository, which we use. So we ask programmers to create some configuration file for us so we know what to do. So he changed it a little bit, and that's a YAML format, and he changed it so it's not readable YAML anymore. So we can't read it. It's just a YAML with the mistakes. So the server is running, the format is broken, and then on the next execution, we're checking what's going on with the container, and at some point of time, the container is finished. So we go to the server, our script, our software, it goes to the server, it gets the information from there, and it tries to answer on the GitHub and say, we just finished with your stuff. But there is a bug in the configuration file, and the software cannot post an answer. It cannot say that something really is broken. It cannot reply because it doesn't understand how the project is configured, because the format is broken. So it cannot close the conversation. We need to do something to close the conversation because we need to give this information somewhere. We cannot just drop it. We cannot just delete it because it's on the server. We need to give this log file somewhere. We need to give this information somewhere. But we can't do it because the configuration file is broken. And we are stuck. We're trying and failing. We're trying and failing. And the entire software it was stuck. And we were down for 5 hours. So we were trying to figure out logically what can we do in this situation. Like, we cannot post the data over there, and that's the problem. And we cannot even report to the guy that there is some problem with the configuration file, because we don't have an email, we don't have any other communication channels. We need to talk in the GitHub, but we can't. So that was a situation where we were down for 5 hours, and this is not probably would happen if that would be control panel system where you log in and click the buttons. So this fragility is a problem which we haven't solved yet completely, because every time something goes wrong, we may go down for a few hours, which would not happen in the case of a traditional system, the central panel system, where UI is in front of you. So that's it. Have I convinced you to use chatbots, or convinced you not to use them? That's my blog. You can read it. There are some articles about this system. But you can ask me questions. I'll try to answer, if you have one. Yeah?
Can you give us more information on how did you solve the fifth problem with conflicts? More specifically in your scenario?
The question is how specifically we solve the problem of conflicts. I didn't say that. I can explain. We have so-called named locks. So we have a system a third-party system, but it's not important where exactly, but it's a list of locks by names. So every time anyone comes to us with a request to do something, we know what GitHub project we're talking about, right? Because we know this issue belongs to this GitHub project. The GitHub project has a unique name, the name of the user / the name of the project. So we get this name and we put it into this lock system, this list of locks. And then if somebody comes in with the same GitHub name, with the same issue from a different issue, but the same GitHub project name, then we just look at this list, and if this name exists there, we just don't touch this issue. We just don't touch this request for now. So that's how we resolve the conflicts, and we just put them in the one line, which is probably the best and the only solution. We tried something else differently in the beginning, but then this is the best solution. Just put them all by names, by the names of their projects, and that's it. That's how we do it. And we use third-party systems. So it's not inside. We use the system which is outside of, it's called stateful.co. You can check it out. Also our project. It's a quite simple, easy, free system which allows you to create these locks by names. It's a RESTful API. You just post a lock over there, and then you ask for a lock later. So it's quite easy, nothing inside us. We just use the outside system. And that's how we do it. What do you think? Still have 10 minutes. We can go to drink tea.
I have one more question.
Yeah.
What about the seventh problem that you had? You didn't actually...
The seventh problem, we're still trying to figure out how to do it. So we don't know. Every time it's a problem. Every time if something serious is happening, the system goes down, and it's basically a mine problem, or we have a few programmers more working on this stuff, and we're trying to put it up again by in most cases now, because now it's quite mature. The system is 2 years old, and we don't have like really bugs which are bugs by just mistakes. We have some conceptual bugs. So we have some like I explained that situation. So we are we want to bring back the information, but we can't technically, and we don't know what to do because there is no way to inform the user that something is wrong with your configuration. And we only got information about that the user itself emailed us, because he knows our support email, emailed us and said, you know guys, I just broke your system because I changed my YAML configuration. I can see that now you guys are down because of my file. But do something about it. And we just said, how can you please fix it back? Like, you know, change the configuration back again. But it didn't help because it was cached on our side. So it was like quite messy situation. Like I'm just giving an example to illustrate that if it goes down, the communication between us and the people who actually caused the trouble is really not so easy as with the control panel system. With the control panel, it's way easier because you show everything to the user, and the user can communicate with you. You always know who is the user. In this case, you're talking to the chat platform, and you don't know exactly how to get back to that user. So we don't know. I don't have the specific solution so far. It always takes time. It always takes some effort to do it nicely. But the more system is developed, the more mature it becomes, the less problems we have like that. So that's probably good. So we don't have many of that issues now. But in the beginning, 2 years ago, we had like every week something was wrong. But now it's quite stable. And it's open source. You can look at the code. You can go to this website, and there's a source code. It's completely open. So it's hosted. It's hosted on Heroku, it's open source, it's written in Java, and it's free. So you can use it for free, you can even contribute to it, you can see how it works inside, you can see how it's implemented inside this chatbot. How it talks to GitHub, how it resolves these conflicts, everything is open. It's not that big. The code is not that big because, like I'm saying, there's no UI, and that's why it makes the code really small. Because we don't have the front end. Well, we have this front end, but it's really easy, just 2 pages. Right now we have about 300 projects hosted. I don't know how many people talking to us, maybe a few thousand, but we have 200 stars on GitHub. We have about 300 projects really hosted, really using Rulter. Many people use Rulter to deploy their stuff to Maven Central, their Java projects, to Ruby gems, their Ruby gems, and some people use it to deploy actually to production, like web systems. And it mostly works with Linux software, Java, Linux. There's no C# way to do it because we're based on Docker containers, and Docker means Linux. So all of these projects are Ruby, Java, Python, PHP, that kind of stuff. No Microsoft technologies at all.
Do you have any idea what's the reliability of your chat code?
Reliability, now it's quite high. Now reliability is high. So we are using it for all our projects. We do software development, commercial software development for about 25 projects right now, and we rely all our stuff on that. So we use Rulter for everything, for all deployments, merge, release operations. How reliable it is? Well, I think it is reliable because, like I'm saying, we put all critical operations we do on Rulter ourselves. But it's just, like I'm saying, it's just simple thing which starts a Docker container, runs the script which you created, and then reports back to you. So there's no you don't need any extra reliability in this case. It's basically a few machines with Docker daemons installed there, and then it just goes to one of these machines, starts a Docker container, runs what you configured, and reports back to you. So it's really lightweight middleman between your chat and the machine. That's it. So that's how it should be. It's really lightweight. So all the hard stuff is done by Docker, and we're just a middleman between the real machine and the person who is talking to us. So it was really intended to be done in a light way, not in a heavy way. Okay. Thank you very much.